inventory matrix. Inventory versus cost. And what you're able to do with these things, it's nothing more than multiplication. If you think about a scenario like sporting goods stuff, let's say you needed football helmets, football pads, cleats, and footballs. It's 4 things, right? You have X amount of dollars to spend, and you want to buy a certain amount of each one of them. Not so much a constraint style, but that's kind of the idea of what you're looking at. What you're able to do here is use a matrix to, how do you want to say it the right way here? To organize your data in a meaningful manner. And what happens is, you wind up with simple matrix multiplication. Now, once again, when we're doing these word problem style problems, am I going to have you crank these out by hand? No. No. Because a lot of these type of problems are going to have decimals, cost factors, you're going to have percentages for investments, things like that. Things you do not need to be multiplying out by hand. But if you're able to set it up in the calculator, you're going to be able to do your inverses rather quickly, or even just straight multiplication, and then you'll start to see how the data flows through. So what I want to do is walk you through a cost style problem, and then I'm going to give you guys this worksheet that kind of works through the same style problem. So here's what we have. When you take an inventory matrix, what we have here are 2 teams. You've got, we'll call them baseball or softball teams, whatever. You got a women's team and a men's team. You have costs for bats, you have costs for the baseballs and things of that nature. What happens is that you're going to figure out a matrix for your inventory and a matrix for your cost. Okay? Now, if I'm looking at this, there are 3 things within my inventory. We have bats, the balls, and the uniforms. Okay? Those are the 3 things that we have to work with. Now, you have 2 teams, women and men. What happens is you just start filling in your inventory. Women have 12, 45, 15, 15, 38, and 17. What they're asking you to do here is figure out what the total cost is of equipment for the entire team. Now, this is a very simple problem. You have a standard cost for all the bats, you have a standard cost for all the balls, and so on. Normally what we would do is just add them together and multiply out and go that route. What you can do via the inventory matrix is set up, in this case, 2x3 matrix for the inventory, and I can multiply that by a cost matrix if I have a 2x3 matrix to start with, and I'm going to be multiplying, what should the number of rows be in my cost one? 3, very good. Remember, they have to match up. 2x3, and then this number here has to be a 3 no matter what. And it works out nice, yeah.
If you do like 15, 12, 38, 35.
You can do that, but then you have to worry about how the matrix is going to look then. Because then you would have, what would that be? It'd be 3 by 2, and then the other one would have to be 2 by something. In order to do your cost stuff, we have 3 costs. I'm not going to get 2 out of that, am I? That's where you start to play around with it. They had a great question here. Can I take this from being horizontal and flip it vertical and make it a 3 by 2? What happens here is that in this case you can't do that. There are some situations where things could work out nicely like that, but more often than not you're going to be forced in a certain dimension so that way you can multiply. So here I can't flip it because I have 3 costs. So I have, what is it? Bat, and I just have to go in this order. Bat, ball, uniform. 21, 4, 30.
You just add it, right?
And all I'm doing is multiplying. Yes, sir?
Wait, so how do you know that they go that way? And then, like, I understand that you can't do them vertical, but like, how do you freeze that out?
it winds up being a lot of times dumb logic. When you first set up the problem, if you set up the problem women and men this way, and did bats, balls, in uniforms, this becomes a 3 by 2. And if I'm going to multiply it, I'd have to have a 2 by something. But my costs that I have are just one column. It's one set of costs. So either I have to go all the way across, which I won't, I have 3 of them, 3 columns with 1 row, or I have 1 row with 3 columns. So that's the only way I can arrange the data. So I have to make sure that that number matches up. So when you first set it up, if you realize that your dimensions aren't going to work, you just flip it.
How'd you get the column on the right? Where did you look?
It was in the next line here. It talks about the cost here.
Okay.
It was given. I just didn't make it up. So then it's just a matter of multiplying out and pressing buttons on your calculator. And what that allows you to do is figure out what the total cost is. What it's going to give you then is it's going to give you a 2 by 1 with 2 rows with 1 column. Those 2 rows now represent women and men. Now, you could have done this many different ways. More often than not, students will see a problem like this about cost with simple inventory that deals with just 3 things and 3 costs. You just sit there and just multiply it out by hand. Generally, a lot of times it's quicker. But when we're talking about in the grand scheme of things, if you're looking at full-on inventory, of like Lowe's, and you're trying to inventory thousands upon thousands of items, it's still a quantity-based system that you can set up via, and obviously this is all done computerized. The things are scanned and barcoded and all that other stuff. It's another way of dealing with costs and inventories. Yeah. Sports are expensive. All right. So this is kind of one of the things we're looking at. Now, when you multiply it out, I don't remember what the answer is, but
882.
there you go. What I have also here is another very simple to follow idea of a problem. And I hole punched it for those of you. Every once in a while I have a decent idea.
I know.
Did you get her flowers?
No, this is like garbage. Started making a garbage.
Bold. So what I want to do is kind of look at this problem here.
Mr. Murphy, we'll do one more.
So here's what we've got. Here's what we have. Mr. and Mrs. Smith have a small neighborhood bakery. The bakery primarily, you guys are probably all freaking out thinking it's going to be a constraint problem right now. The bakery basically sells sweet rolls, bread, cakes, and pies. The amount of eggs, milk, and other ingredients required to make these baked delicious goods is given in the following table. Blah, 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 blah. The unit costs for each ingredient depends upon whether the ingredients are purchased in a large or a small lot. Whether or not they went to Sam's Club or they went to Hy-Vee. Think of it that way. Buying in bulk, you get a little bit, usually get a pipe. A lot of times, I mean, the more I go to Sam's Club, the more I'm like, I'm not really getting that good of a deal. And I had to drive here to do this. Yeah, but that's what they do. They make you feel like you are.
Good.
Yeah.
It's $7 a pop.
Anyway, so you've got cost stuff here. So what I want to do here is think of this first table as table A. The second one is table B. And what I want to do is create some matrices and what the information looks like. Now, if I'm looking at this information here, what would the dimensions of that first matrix wind up being? How many rows and columns do we have? Please take the earphones out. Well, you can do that outside of class because I'm not teaching that now. Come on. You don't have to give the attitude about it, but that's why I do these things. We do those outside of class, all right? I know, I'm a jerk. Sorry. If you have other questions, you can talk to me later, okay? So in this case here, what's your dimensions going to be?
4 by 5.
4 by 5. Do we all agree? There's 4 rows and 5 columns. So when I go to start writing this one out as far as what an inventory matrix would look like, I'm just going to look at the data here. And I'll come back and forth via. So my first matrix is going to be 4 by 5. I would just write it down for now. There's a spot in here on the sheet itself that says what's matrix A going to look like. Because you're going to start multiplying things together here in a second. I'm just going to get you guys started here.
Is there going to be a review packet for the test? No, you have to figure out wait, so all you just do is copy it on the table?
That's all it is. Because when you're dealing with an inventory matrix, and especially if they have a table set for it, that's all it is. It's another way of representing the data. A matrix is nothing more than data representation. That's it. Now also, there's a part B here. And it also, or excuse me, a matrix B. Take a second, figure out what the dimensions are going to wind up being for the second matrix as well, and fill that into the same spot. And when you're done with that, read the next question. You guys have gotten into that multiplication portion?
We didn't have to do anything with terms, right?
No.
All right, so you got
All this said was just multiply matrix A times matrix B. With any luck, you guys probably have the following information then. When you did that, you get 65, 78, 75, 32, 39, 75, 81, 95, 34, and 41.5.
Oh, I did that one, so that's all.
That's
315 over 4.
Oh, yeah. This is cost. Yeah, remember, we're dealing with cost stuff here, so you just keep them in decimal values. You're talking about money. Now, here's what I want you guys to understand. Think about the things you just multiplied. The first matrix, that matrix A, matrix A was a 4 by 2. No, excuse me, 4 by 5. Sorry, thinking about the other one. It was a 4 by 5. The matrix B was a 5 by 2. Do you agree? What did the 4 represent?
The number of
different
types
types
of taking the last round.
Types of food. This is your baked goods.
Or baked
This was your what?
ingredient.
ingredients. This was your what? Ingredients. And this is your costs. Notice how the column and the rows match like that? What you're doing here is you're figuring out the costs of the baked goods by using the matrix. It's not that difficult, is it? And I think that's where you were getting into the next insider, right? The next couple of questions of what was it representing. Does that make sense of what it's representing? Because once you start to identify what you're looking at via the matrix itself, these are easy stuff. The worst thing that's going to happen is that you're going to wind up with some silly flubs on your calculator. So right now, let's see. Today's order in part C, well, let's see number 4 here. See if you can figure out the last couple now. Take a couple of minutes and see if you can figure out those last couple of questions. You start looking at what they're talking about in question 5. They're asking you to use that matrix C that you came up with, and that was your order. And it was 20 rolls, 200 bread, 50 cakes, and 60 pies. Okay? That was the order that they were giving you. Yeah, you like that? This is a 1x4. Now what they're asking you to be able to do here is if you look back at the other stuff, it tells you what information it needs. So what you're trying to figure out here is the amount of ingredients that you need to fill today's order. So if I'm going to be multiplying stuff out, I have to start watching my dimensions. So if I'm looking at working to figure out total, what do you want to call it, ingredients here. I have this 1x4 of my order, which means I have to start figuring out how many multiply this stuff together. That means the other one's only going to have one column, right?
Yeah.
How are we going to do that? Now, if our ingredients matrix is a 5x4, do you agree?
Yeah.
My ingredients matrix is a 5x4, what do I have to do my order matrix? If I flip it, if instead of it being a 1x4 and I create it as a 4x1, will that work?
But how does that still just work when you have to match them up?
You do. Now look at what you have. You have to put them in the order. Look at your matrix A. Your matrix, or sorry, let's talk about table A. If you look at table A, it goes rolls, bread, cake, and pie. So if I flip this, it would just be 20, 200, 50, and 60. I just have to keep it consistent to what the ingredient matrix was going with. Does that make sense? So what you're doing here is you're using the dimensions in order to make this work. Now, here's the grand scheme of things. Have you guys ever heard of the thing on computers they have nowadays called Excel? It's so much easier to do inventory stuff like this via Excel. Because all you have to do is you do these little if this, then that. It's a little programming stuff. It's a little bit cleaner instead of using a straight matrix to solve a little bit of this stuff. But this kind of gives you the idea of what you're able to do. Okay. So that's what you're working through in this one. From here, I'm going to leave this be. I'd like you guys to finish those 2 questions. We'll revisit that tomorrow. But there's one other style question I wanted to talk about. Page number that one's on. 5 by 4, 4 by 1?
It's a 4 by 5. It's a 4 by 5.
Oh, is it 4 by 5? My God. You gotta flip this one too. Yeah, flip this one.
You don't have to flip them. Yeah, you don't have to flip anything. You don't have to flip anything. One time. So it's a 1 by 4 and then a 4 by 5. So that'd be a 1 by 5.
You flip it.
I flipped
You
it wrong.
flip, you do the 1 by 4 times the 4 by 5.
Why is this small like that?
Yes, you do that one first. 1 by 4, 4 by 5. You're right, I didn't have to do it that way. I could have gone right to the 4 by 5. Yep, that would have worked too. Sorry, I was thinking about going the other direction. It's all right. Now, the other thing that works really nice, do you remember how we were setting up these problems with inverse matrices, and then we were solving systems of equations via inverse matrices? When you take the coefficients, and you had your solution sets, and you just kind of put them in the calculator, hit the inverse button, and you were done, it made systems easier. So the other style problem that I wanted to give you guys tonight is out of, let's see, I'm going to get the right page here. And I've got this file for you, just to show you guys. This is 4.
Can you just multiply this matrix by the
Anyway, let me just give you this sheet. There's a couple of the other ones. It deals with systems that I'd like us to look at.
Oh, you put this one in front, you don't have to change it.
You would times that one by the equation.
Hey, can you imagine if I was having to do this stuff by hand? Because these is when you would do that stuff by hand when you first learn how to do it. There's no way I would have to do this by hand. Can you imagine multiplying a 4 by 5 and a 5 by 4 together? No. No. Now, on the stuff that I just gave you guys, I would like you to look at on the 219.
Is this 219 in the packet, correct?
Yeah, it's right. It's also in your book. I just, instead of you guys having to do open up multiple pages on the PDF files, I just figured just run off a couple of word problems here. I'd like you to try those. We'll finish up the cost of the bakery stuff tomorrow, but I want you to try these. Now, granted, they're jumping between 3 or 4 or 3 different sections, and each section was either dealing with Kramer's rule or determinants and things of that nature. But for the most part, what you're able to do here,
So this is due tomorrow.
yeah, for the most part, these style problems will all be able to be solved via inverse matrices. A lot of these things are dealing with, remember, Kramer's rule was a long version of doing an inverse. The other one should work out real clean. Now, you'll have to set them up as a system of equations to start, but then use your calculator to solve them. It's much easier to use calculators instead of by hand when you're talking about systems. All right? We'll give those a shot. We'll finish up that bakery thing tomorrow. Then we'll talk about cranking out an inverse by hand and go from there.
Is this also due tomorrow? I don't know how to do it.
The area of the triangle is in the, we did the formulas in the book. You split the ordered pairs. It's at plus or minus 1/2. Your ordered pairs go here, and one's here. That's all you gotta do. All right.